Okay. Again, thanks for joining us for the PM session, Alternate Control Design Approaches for ZOS. Again, this session will get into a lot more details regarding some of the issues that were being confronted, talk about inherent control design issues, how traditionally we try to lower the risk levels of those issues through remediation strategies, but we do fall short in many cases. We'll talk about what are some of the solutions for that. In regards to this material, again, a lot of details we'll be going into. Feel free to ask questions. Again, the overall objective, again, looking at those design considerations within the mainframe environment, but some of these issues extend beyond the mainframe and can apply them to your distributed environments and your mid-tier environments also. When we talk about the ZOS environment, we will talk about the traditional ZOS, which derive from MVT, MVS, and OS 390, versus environments you guys still might be using now, migrating your Unix environments to the ZOS environment. So we also will talk within the Unix context. This is a list of topics we will be covering as part of this PM session. Just a quick preview on that, and we'll drop into extreme detail within each one of these areas. We're talking about the inherent security that RACF provides some level of security. Also, the operating system itself provides certain level of security. If programs are running in program states, if they're running in supervisor state, then they can bypass security checking. That's why we need an additional security ring to go around our environment to make sure that inappropriate access is truly identified and prevented. On the second bullet, we'll be talking about change management processes used to manage system-level types of changes. The third bullet, we'll be discussing one of the issues we all have, which is the degree in which we manage and control production support. The fourth bullet, we'll be going into understanding that all application software components are not necessarily managed through a software change management system. There are many software components potentially managed outside that process, and what control capabilities we can implement to control those areas. On the fifth bullet, we'll be talking about the privileged access functions of the data center, which you have to give them in order to perform their job function, but how we can better control and monitor what they are doing. And the second to last bullet, we'll be talking about the inherent problems of ZOS, in which there are certain system processes that will bypass RACF security checking. We'll talk about what they are, how you should control them, and put in some control solutions for that. In the old audit days, we used to call that our straight MVS system reviews, and obviously we've upgraded that for ZOS. And then finally, some of the key subsystems within ZOS where it's specific to the mainframe environment, knowing that we have JES2 and CICS systems definitions that have to be controlled. We'll talk about control alternatives for managing those subsystems. So let's go into each one individually as a section. So first thing is we want to look at establishing an additional security ring around ZOS and Unix. And the way we accomplish that is we understand that there has to be some level of business online access, which is, so most of our systems are real-time applications, GUIs, front ends. Obviously, ZOS has been changed to make them web-enabled transactions, so it's obvious to see, obviously, a mid-tier solution that's allowing for web pages to be generated, which gets translated to CICS transactions that then execute within your system, or translates to Unix transactions. We have business level still. We're doing a lot of batch level activity where we give TSO out to not only developers and support people, but to general users to edit various things that are used and pulled in during actual production processing. What happens still quite a bit in a mainframe environment, I see all the time, is the use of control cards that are managed by the user groups, and those control cards represent actual data input that's going into the system. And the reason why those exist is that an investment was not made to build online interfaces, CICS transactions, to capture the input in the proper fashion with all the edit controls. And they actually continue to put into 80-column control card files based on position represents what data is going in and being brought into the system during batch processing, which represents data input into the system. Still goes on quite a bit, which is the reason why there is still a lot of JCL changes that are being made, because they're pointing to different control card files or actually editing the system statements directly in the execution JCL. And obviously we have, as part of security ring, we need to control application software changes to the overall application programs, looking at the job control language, which controls all of batch processing and how it pulls programs for execution and files that's being updated to make sure those changes are managed properly. Batch jobs are the main components of that. Production support data sets, obviously there's application management when there's problems with the actual data files themselves that are based on application failures. System support is going in, making their changes to the system programs and various system parameters to get the system working again. There's always a bunch of storage management issues that system support is doing, which they need privileged access to the system. Data management is an ongoing issue with most organizations where direct changes of data have to be made in order to correct data errors and corruption. So a little diagram to describe how it's pulled together in a straight ZOS environment. I look at everything being in the case where it's actually controlled at the actual data level. Get my trusty pen out. The edit button. That's it. Okay, there we go. So here we have is the data is the holy grail that we're looking to protect. And obviously the data is actually being managed, hopefully, through our OS level access, in which RACF is our security system. As part of the data, it's either stored in a database, or it could be in a file level access, VSAM, sequential files, all your interface files, certain files that are loaded into the database that pass from upstream systems to downstream systems, are all going to be part of our unstructured data, but we're hoping all that will be controlled by RACF. Programs are being executed as part of batch processing and online real-time processing, and those programs get access to the data itself. Again, hopefully there is RACF controlling who has access to the directories which store those programs. Going outwards, in terms of protecting access to the data, we then look at the actual OS level access that's on our systems. As part of the program level, just jumping back, we have job control language and catalog procedures, which is the method in which we execute programs and define which data we're updating. The actual kick screens are the online transactions are stored there. Those are all definitions that are programs themselves that can be triggered from a web server and through the internet. Then the next level of access to the data is, again, the OS level access. Who are the systems programmers that have access to the environment? Knowing those OS level access potentially could bypass security checking, that we'll get into later. If they're running as an authorized program facility, authorized programs, if they run in a certain way, they will bypass all RACF security checking and would be able to open the data set even if they have no access to the data set. Same thing if I have supervisor calls that we'll get into under the system program section. If I have ability to make supervisor calls, I can create them in a way, again, in which it will bypass all RACF security checking, be able to update your program data sets, it will update all your data. Hopefully these are all restricted in a proper fashion that we'll talk about in later sections. But that's the one thing you have in a mainframe environment that you don't have in a distributed environment. Because traditionally all programs run in problem program state, which means it goes to a normal open that will call RACF security checking. If you're running in this fashion, you're running in supervisor state, which does not call RACF on an open, and that's why it bypasses security checking. Good. And what we're saying over here is event action as part of these calls, besides RACF being called as part of security checking, if those data sets are defined to being tracked by event action and restricted, it will also be called, and you will generate a failure also if you don't have access from an event action, which is why it's critical to identify all of the data sets and all of your environments that you want event action to control. The beauty about this, the way the open's being done, even if you're running in supervisor state, it will not bypass event action checking. So that's one of the proponents of why we call this the additional security layer. Because again, a lot of people's attitudes is, oh, I don't need to control the systems programmers. It's not just systems programmers. It's your ZOS systems programmers. It's your KICS programmers. It's your VTAM programmers. There's the DBAs. There's a whole slew of people that have this privileged level access that you look into control, especially in larger environments and larger banks. You know, when I worked at Citibank, you know, in our mainframe environment, you had upwards to 25 people that had this level of access that can get access to this and bypass all of security. But back then, the attitude is, someone had to have the keys to the kingdom. That was the term that was always given. In this world, 20 to 30 years later, that's not the case. No one should have the keys to the kingdom. There has to be some level of accountability. Changing this for how things work in a Unix environment, it's a little bit different. In my experiences in Unix, the structure of the online environment is quite different. Everything is basically closed and accessed by users, running in a command shell where all the users, in many cases, have access to the underlying directories which store all the data, but they're in a captive mode where they cannot break out to the command line to actually use that access. That's how a lot of Unix systems are built within environments. So based upon that, you still have file level and database level access. And RACF would be called as part of the security checking. They don't have the similar process as you have in straight ZOS, where your things running in supervisor state that would bypass security, so you don't have that same level of concern. But again, USS action would be called on all the opens to see, hey, is this a directory or a module of the directory that's controlled by USS action? If it is, it will be called. Yes, Hugo, you want to interrupt?
Just a very brief thing. You can actually run programs in
supervisor
special state.
You can within Unix.
You can set the bit to say you can do anything you want.
In Unix.
Yeah.
Okay, so it has the same attributes as the AC code we have in ZOS, setting it to 1. You have something similar in Unix. And then based upon that, the same approach would be is they would bypass RACF security checking, but in this case, it wouldn't bypass the USS action open that occurs. So you would still capture the preventive controls if you're not allowing access to the data set, the tracking to say who changed it, if you required a change request to go through, or if you're requiring them to get certain approvals, it would fall all under the umbrella of USS action to have those levels of controls. Okay. So again, from a security model standpoint, we always look for access to be granted based on principle of least privilege that's required to perform the requirements of their job function. Again, access is granted unless, again, it presents a potential SOD conflict. So even if you have a case where someone requires it for their job function, but you realize that that combination of access allows them to dominate the life cycle of a transaction, we can't give them the access. Well, when that actually occurs, that tells you that the roles and privileges that they've structured within their environment were not thought out very well because it violated SOD conflicts. So again, the ultimate thing is that if it's an SOD conflict, you're not given the access. But assume it does not violate the SOD conflicts, it's required for their job function, then you would give the person the access. Unfortunately, I find in the course of my audits that most organizations don't have adequate SOD matrices that truly drops down to the business operational level to identify what are the functions that truly need to be separated to ensure that someone cannot dominate the life cycle of a transaction. And then within the IT areas, there are functional areas that always require some level of separation. So in a typical world of application development, if you have a SQL Server environment, you're writing stored procedures, typically we refer to them as application DBAs would work in the development group. Did you have a question? No. The application DBAs would work in the development group, but you have your system or infrastructure DBAs that one would have the DBO access to perform the elevations. So there'll be a clear separation of duties from the people developing the code versus those people on the DBA side that impact the table structure, the creation of tables and indexes, and everything else. So there should be a matrix within IT of the various functions. The more difficult part is understanding what are the combination of business operational function that represents an SOD. It's not necessarily an SOD that would allow someone to perpetrate a fraud. That's the first objective. It's just a matter of who can dominate a transaction which would bypass the oversight controls. And if you have to give someone too much of that access, you're going to need more tools in place to provide visibility of what activity is actually occurring in order to set up a detective review process. Continuing with that theme of least privileged access, again, we're talking about individuals that are granted access to sometimes very sensitive resources. Again, it's required for their job function to perform those updates. But we know based on that access, they could potentially perpetrate a fraud. It's not a case where we can divide up that function. It's the way it's structured where you cannot further segment it and provide an SOD. The issues we have is they might have proper intent of making the right changes, but there's always going to be human error on making changes that are being made, and what are the audit trails we have in place and review processes to identify the human error, operational error. Versus just the general need to have some level of oversight control because we want to have sufficient audit trails to perform this type of review. We want to make sure that all of the functions performed by this person who's been granted the access based on the job function, are they doing proper functions all the time or are they not, and can we identify it through actual audit trails? So in terms of the security ring, again, RACF provides global access privileges for support personnel. We need a way to identify the sensitive data sets that they're updating. So we need to know upfront what is considered the sensitive data sets or directories in the USS environment that we have to have special monitoring for people that are granted this access, but we want to have some level of oversight control. We want to track those changes they're making to the actual system program. So in this case, we are managing specific data sets that we've identified as being important. Obviously, systems programs are stored in the Mac IBM, in the Sys1.IPL my procs, my system procedures, my starter tasks are stored in my proc lib. On the system side, we could track the changes. We can require a change request in certain cases if we want it. We can go as far as suspending it, where we just prevent access, or we can say it requires an authorized request to make changes. We know that they have to have access in the middle of the night, so we allow forces of the changes to occur. And does have to be part of a coordinated schedule of applying those changes within a period of time. So grouping this within an OID will allow us to control a whole set of sensitive resources based on the level of control that you are looking to achieve. And again, even if the person has normal access and update access to all these data sets, you're saying I'm putting an additional security ring around that in order to provide accountability for certain types of the sub-resources they have access to because they are so sensitive. That's why it's very important to assess privileged IDs that have privileged access. If you can't cut down the access, then you really still have to determine what are the sensitive resources that you still want to have more oversight controls, preventive controls saying I need authorization before they're updated, but I'm still going to allow them to do the updates. The additional oversight controls are critical. So obviously the benefits of this security ring that we're providing through Event Action, USS Action is authorization prior to update. So for certain things that are not managed through traditional application software management systems, and when we're talking about system software changes, they are not managed through RTC, Endeavor, and all of those products. They are managed separately. They're managed through SMP, as we'll talk about later, but that's not a security system. That's just a method for applying and delivering updates. It does not provide a security ring. It's still just saying who has RACF access to it. We can control system parameters, which the systems programmers, the KICS programmers all have access to make updates. We want to make sure there's approval prior to making the updates to make sure they were proper and appropriate. Batch processing components, obviously, if we have users that are updating control cards, there is no change management for that. Never mind not having good edit checks to make sure they're putting in proper data, but we're not going to have audit trails for any changes at the individual change level. We can actually at least turn on audit trails for all the control card data sets that they're updating on a daily basis prior to batch processing, which again, in many cases represents data input, just like going through CICS. We want to have security and control. Right now, the way it's set up, we just give a group of users as part of a RACF group, gives them access to all the control card data sets, and then they update it and they're tied to specific applications. We need to get a better understanding as auditors how they're using control cards to be the replacement of data input of normal CICS. If they're doing that, I guarantee it's not controlled through Endeavor or any of these processes. They just have routine update access with no audit trails of what's being changed. And this is production data that they're changing. We can use event action to track all that, at least provide an accountability of what's being done, and if they're really sensitive, we can require a change request or authorization prior to the updates being made. And you definitely want to tie it to a specific window in which they're doing the updates. Because remember, these control card files, if it's part of a daily scheduled job, are pulled every single day. You want to have that change window that says, make your changes from 2 to 6 before I run batch processing, and you know they're going to be required to make the changes during that window, right before it's pulled in during batch processing. So you can tie it to your whole scheduling window also. Execution JCL, again, most environments that I deal with, execution JCL is not being managed by my change control system because there's so many changes being made to the execution JCL. How are you managing it? The way you're managing it is you're either giving them access to edit it through your job scheduling system through a privilege in which the audit trails are very weak in terms of you have no accountability of what actual changes are being made, or you're controlling it outside the job scheduling system, just giving them TSO edit access to the JCL execution library. They can make changes there, they can pull things from their personal library, they can change where the control cards are being pulled from, which is data input from your personal libraries. Why not have that all managed by event action in a passive mode, giving you audit trails, or a more active where it requires a change request or approvals prior to making changes. And it's not one size that fits all. For certain, because you have multiple execution JCL libraries. For some of them, you put stuff that only requires audit trails. For other execution JCL libraries, you might want a much more higher level control, such as a change request or even an approval. So this is an example of providing privileged access to support personnel. And in this case, we also realize that some of that privileged access that we're given are not necessary to individual IDs. It could be system processes that are actually running. Well, those system processes are considered authoritative sources of where activity is occurring. I don't need to pick up all that logging and include that in my analysis. So what event action allows you to do is to actually exclude certain starter task names that are updating specific target data sets. So I'm only picking up the updates to the target data sets that are of individual users versus approved system processes. So again, one thing about audit trails, you don't want them too voluminous. So you want these exclusion processes to only get meaningful data that's reasonable to review. Also, as part of that security ring, we only want updates to occur based on a standard release schedule, a specific time frame. There might be some critical dependencies, which I cannot manage to my job scheduling system through the triggers that are set up through there. So obviously with an event action, we can indicate the time frames in which changes can actually be made. And obviously the other beauty about this is we can prevent concurrent updates to make sure only one person's doing the update and not someone else is actually doing the update. So we want to enforce also the use of change requests as part of this security ring. We want the accountability of the changes that are actually occurring. And also, most importantly, as I mentioned previously before, there's certain ways we can run our system processes which bypasses RACF security checking. 2 ways, obviously, the issue a rack route request equal auth and turn the logging off to none. It would not generate any log records that could be reviewed by RACF. Or if it's an APF authorized program, I just link it with an AC code set to 1. It totally bypasses RACF checking because it's running in supervisor state, no longer in problem program state. So that's the security ring that we've been trying to do and try to realize that we need more security mechanisms to provide the additional security levels that we're looking for.